Oh, here you go. I can see.
Okay.
Okay.
All right. Good luck, Arya.
All right. See you, Chris. Okay. So basically, we're going to go over how to make a pegboard with pegs, and also we'll do a little bit of engraving. And after we create all the parts, we'll kind of build an assembly to make the final pegboard with the pegs installed into the pegboard. After that, if you have any questions, just let me know. Throughout this entire process, there's only 2 of you right now, but if it's interactive, it's going to be much more exciting. So if you guys have any questions along the way, just kind of, interrupt me and ask. I'll be more than happy to answer any of your questions. Okay. Yeah, so a brief overview of what CAD means. So CAD is basically the process of using computers to design objects. It's mostly used in the field of engineering to create blueprints, to create, initial product designs, which, you would send out to a manufacturing team to actually manufacture. So it's really like the new way of, kind of jotting down a rough design, a rough sketch that you have of a new idea, of a new product, which you can basically use to kind of show to other people that this is what we want to kind of produce, or we want to market, or we want to build. So there's a lot of cool things that you can do with CAD. You can create simulations to see whether a certain part, a certain prototype might work in certain fields, in certain settings, in certain environments. So there's a lot of simulations that you can do. You can, get accurate dimensions using CAD modeling, and you can basically kind of understand, or people can understand your product a little bit more if you kind of create a CAD model of your design. So here is the link to where you can download SolidWorks. Also, you can download AutoCAD and Fusion 360. These are all available to CPP students. So if you click on this link, it'll provide you with the process of how to obtain these 3 different softwares. They do pretty much the same things. However, also you can get Inventor as well. They pretty much do the same things. You can use them to kind of design your products. However, there are certain things that SolidWorks has that perhaps Fusion 360 does not have. SolidWorks is a little bit more complex, has a little bit more options and tools at your disposal. But you can definitely check all of these out and start working with them on your own time. They're all free to use for CPP students. Okay. So next slide. So this is what we're going to be making today. It's going to be a pegboard with different pegs in the middle with some extrusions, and also there will be these side these side slits which is going to hold the pegboard in place. So we will create each one separately, and then we'll kind of attach all of them together. Also, we'll kind of engrave, some lettering into the pegboard, and then kind of change the materials for the pegboard and the pegs. So we'll see how that works. So any questions before we start? What I'll do is in the chat, let me see if I can do this. Actually, okay, I can. So basically, if you go under resources on Discord for CPP Hyperloop, you'll see that I've kind of pasted an activity or today's activity, and this is going to be the dimensions that I'm going to be using when creating the SolidWorks parts. So if you want to look at that and kind of follow along, that would be great. And again, if you have any questions regarding that, if you can't access that, please let me know, and I'll try to get it to you somehow. Okay, right. Okay. So do you see my SolidWorks screen? Someone can give me a thumbs up. Okay, I'm pretty sure you can see it now. Ultimately, so let's start. Anthony, hey Anthony, so I know you just joined in. What we will be doing right now is we're basically going to be going over how to kind of view SolidWorks, and we're basically creating a pegboard with different pegs. So I've kind of under the resources tab on Discord, I've kind of posted the link to the file that we're going to be using to kind of understand what dimensions we're going to basically kind of work with. If you want to kind of use that and go off that and follow along. Okay, so once you open up SolidWorks, you choose parts, and this is the screen that you will end up with. And first thing you do is you go to Sketch. Before you begin creating any design, any part, you have to create the 2D sketch of the surface. So if you look at, let's say, the front plane is ultimately what you would basically kind of have if you're looking from the top surface, right? So this is the front plane, and this is where you start drawing the 2D sketch. You go to Sketch, and you start drawing the part. So ultimately, so we'll start with the round peg, and as part of the round peg, what I'll do is first I'll go to circle. I'll create a circle. So this is going to be basically the circle part of the round peg, and I'll give it dimensions. So if you press on Smart Dimensions, it's a pretty cool tool because you can press on it and you can give the dimensions for diameter or length or width or whatever it is, and it will kind of keep that dimension in place in respect with other dimensions that you add later on for other other geometries. So this is going to be 1 inch in diameter. Okay, so you just press 1 inch, and then this is 1 inch in diameter. Get rid of Smart. You get rid of you. That's okay. You exit the sketch, and now you go to Features, and you press Extrude Boss or Base. This is basically going to blow up this circle and create it into a 3D model. So if you press Extrude Boss Base, you can see how now this is turning into a 3D model. Here is going to be basically the length of the cylinder, and as per the PDF file, this is going to be 3 inches. Okay, so that's okay. So now we have a 3D design of the first peg. Now, a cool thing we can do is we can go under materials and specify what type of material we anticipate this to be. So we can go to Edit Material, and there's a list of different materials that we can choose from. And this is a really good tool because, you know, if you plan on manufacturing this part, then before you start manufacturing, you can get a better understanding of how much it might cost, depending on what material you're using, what the density might be, and all the other different material properties kind of associated with that metal or with that part. So let's go to wood, and let's see it's pretty cool. You can see the color change, and here are the properties. You know, the elastic modulus and Poisson's ratio, and all these other material properties are pretty valuable to us when we're designing. Press Apply, and now you can see that it's basically kind of colored itself in a way where it's wood. So this is going to be the first part. Once you're done creating the first part, you go to File, you have to save it. Make sure to save it in the same folder. I'll save it under Downloads I'll save it as round peg. Okay. And now if you want to create a new part, you go to new, press part. Okay. So now basically we have a blank screen again, and now we can create another part. Like we talked about last time, first you choose sketch, then you have to choose a plane to draw the surface area, to kind of draw the first geometry. We'll choose the front plane, and now we'll draw the second peg, which is going to be a rectangle, will be a rectangular prism. So let's press on the rectangle. Okay. So as for the PDF, this is basically going to be a 1 by 1 by 3. So this is going to be a square essentially. The surface area is a square, and the length will be 3 inches. This will be 1 inch. Be 1 inch. This will be another inch. Right. So now this is essentially a square. We exit out of Smart Dimension, and we exit out of the sketch. Now, since we have the profile, we can go to Extrude Base. And just like last time, we can give the length of 3 inches. And now we have our second peg. Again, if you go to materials, edit material, we can make this a different material. We can, choose from iron. There's all these different types of iron that you can choose from. So there's ductile iron, gray cast iron with different hardnesses and different kind of ductility. Let's choose gray cast iron. We apply it, and you can see the color changes as well. As you can see, sometimes you can see some textural changes as well. Again, you go to File, you go to Save As, save under Downloads as round peg. It's really important that you save it under the same folder, because if you don't, when you're creating your assembly, when you kind of attach everything together, it's square peg. Yeah, so you want to have it in the same folder, because if you don't, then when you're kind of assembling everything together, it's going to be very hard for you to kind of get access to those files. And SolidWorks doesn't really work if you don't have everything together. Again, so we'll do a new one. So will be the third peg, and this is going to be a triangular peg. It will kind of be an equilateral triangle. Go to Sketch, choose front plane. Now for triangle, what you want to do is it's supposed to be, in terms of height, it's supposed to be 1 inch. Okay. So we'll draw a line, and then we'll give it smart dimension. We'll give it smart dimension of 1 inch. 1 inch. Okay. Now what we can do is I'll do this. So now we're seeing that we can now start forming a triangle. Now, since it's an equilateral triangle, all the sides need to be the same length. The only thing we know is that the height is 1 inch. So what can we do to get the lengths for this? Now we can use the Pythagorean theorem to kind of get a basic idea of what those lengths are going to be if we kind of consider this as a right triangle. However, an easier way you can do that is if you look at the angles. So an equilateral triangle would have a 60-60-60 triangle, or 60-60 angle, 60 degree angles at all sides. So this one should be around 30 degrees, right? So this is just half of that. It's only half of it. This should be 30 degrees. Okay. Now, I'm going to do this. Okay. I kept this on purpose because I wanted to show how you can use trim entities to cut this. So if ever, I'll do this again. So basically, whenever you might have some types of, errors, like let's say I made this length a little bit too long, you can go under trim entities and cut a small portion of it. So now we can draw it the other way too and kind of attach it together. However, an easier way is to go under mirror entities. And you can actually mirror these two lines about this line. And now you can see that we created a triangle, an equilateral triangle. This to make it easier when you're kind of extruding the triangular base, you can change this solid line into a dotted line. The dotted line doesn't have any kind of definition, kind of in comparison to the solid lines. So once you exit the sketch and once you go to features and extrude it, as you can see, it's considered an entire full triangle, not two triangles with, with that dividing line in the center. Now you 3 inches. Okay. So now instead of going under materials and changing that material again, what we'll do is we'll actually color it and we'll give whatever color we want. So if you go to appearances, you choose the entire body. Okay, now there's this kind of coloring palette you can choose to kind of color the entire thing. So I can choose something like yellow. Right, now we have a yellow triangular peg. Again, we save as trying peg. Save into the same downloads folder. Once I'm done with that, now we'll kind of create the pegboard itself. So we got all the pegs kind of designed. Now we will create pegboard itself. So again, we go to sketch. We choose the front plane. You can choose any plane that you want. Doesn't really matter. But we'll stay consistent for this time and just choose front plane for all the parts. So again, now the pegboard is square. So we'll choose square. We'll kind of create the front profile of the pegboard. We'll give it dimensions. So basically this is going to be 5 3/4 of an inch. 5 inches. This is going to be 3 inches. Okay. I'm going to exit and I'll extrude the base to a height of 0.75 inches. Okay. So as you can see now, we kind of have the base of the peg. The only thing we need to do now is to create the holes for the pegs. One thing I forgot to mention is that if you go under options you go under options, you can change the units. You can change the units. So I know I'm using inches, but later on, if you want to use centimeters, millimeters, meters, you can choose the unit system that you would like to work with. Just in case if you have any preference, or if you're sending this out to a manufacturer and industry, if they have a preference, you can always choose different units. But we're sticking with inches for right now. So now we have the base, but we don't have any holes. So what we can do is we have to choose the front profile, the front surface area of the pegboard as our new plane. So I just click on it and then I press sketch. So now this is going to be my new plane. Now I can create the 3 different inserts. So let's do the round insert first. So I'll do this. Remember, the round insert diameter was 1 inch. That was the diameter for the round insert, so I'll give it 1 inch. Ideally, you might want to leave some room for tolerances. You know, you can make this maybe, actually, let's do this. Let's do 1.01 inch, just because we need a little bit of room to kind of fit those pegs inside. In real life, you would have some sort of tolerance or some sort of clearance, so we're able to fit, fit the inserts through the holes. Then we can do the square one. Okay. So we know it's a square, 1 by 1, 1 inch by 1 inch. Give this 1 inch. We'll give this 1 inch. Okay. So now we have this as well. Okay. And now what we'll do is we'll give the triangle. It'll kind of be like the same thing like last time, since it's the equilateral triangle with a height of 1 inch. Okay. 1 inch. Actually, let's move this a little. Let's move this a little bit closer. See, as you can see, if I kind of press on that line and drag it, you can kind of drag it horizontally if you want to put it in a different place. Okay. So now let's choose a line. Okay. Do this. We'll give this a smart dimension. This is going to be the angle. We'll make this 60 degrees, lateral triangle. And now, again, like last time, we will mirror the entities along this dotted line. Okay. You know, as you can see, we have 3 different pegs. We exit. Now, so basically, once you exit the sketch, they'll show you the sketches that you've made. Instead of choosing extrude boss this time, we would go to extrude cut, which has the opposite effect, which now you can use to cut through the base. The base is 0.75 inches, so we'll press OK. And now, as you can see, we have a base with these 3 holes. So we have that part done. Go to save as, save it alongside the other part files. We'll call this pegboard. Okay. File. So now we'll basically go back to Sketch. Now we're going to be kind of creating those the ends of the pegboard, the stands. A sketch, use front plane. And now, according as per the PDF, it provides us with the side profile, and that's what we will use to kind of create the pegboard stands. So we'll go to the line, and we'll start here. We'll go towards the right. And I recommend that whenever you're kind of making a complex geometry that isn't just a simple square or a circle, every time you draw a line or a curve, always give it dimensions. Otherwise, what might happen is that you might kind of draw everything, and then if you decide on giving it dimensions, there might be some instances where it might not work just because you kind of attached all those lines together. So if you don't want to run into that problem, I kind of recommend just give the dimensions, as you go along. Okay. This is going to be 4 inches. It's going to be 1/4 inch. Okay. This will be 0.375 inches. Okay. And then keep on going down. This is going to be 3/4 inch. 75. Okay. And after that, we just kind of connect the dots together. Solidworks is kind of fun in this way because it's like you're kind of connecting the dots like those puzzles. So now we kind of have the side profile of the end. Exit sketch. You have the sketch. You go to features. Same thing like last time. Extrude the base. It will be of a depth of 3 inches. Oh, wait. Okay. Wrong. So, okay. See, this is the problem. So the reason why it wasn't working is because this isn't connected. It didn't know that this is a complete geometry. It seemed like they were just lines. I guess I forgot to connect this together. Okay. Sketch. Okay, see now it works. You press 3 inches. So now we basically have the ends or the kind of stands. We'll be using 2 of these. We don't have to make 2 because we already have this one part done. We can just kind of make a copy when we're making the assembly. So we'll save this piece. Okay, this is called stand. I'll save it to downloads. Now what I'll do is I'll go to file. I'll press make assembly from part. So SolidWorks kind of has three primary functions. The first is that it can create parts. It can create assemblies using different parts, a bunch of different parts, and then you can create a 2D drawing of an assembly or a part. A 2D drawing is basically kind of like a PDF version in which you're giving where you're stating the dimensions and the angles of different profiles and different geometries of the part. But this is the assembly, and here we can see that all our parts are listed here. Choose Pegboard. Pegboard. Okay, so now we have Pegboard. Go to component. We can put something in, put another thing in, put stand. Insert. Another stand, we'll need 2 for both ends. So I'm just kind of dragging it inside. These are components, square peg, round peg, and then we need triangle. Okay, we kind of got all these pieces in. Okay. Sometimes these parts might be fixed, like that one was, which means I couldn't move it. If that's the case, you can kind of go here or change it. So it's like this one's floating, so you can move it. If you fix it, then you can't move it anymore. This is useful sometimes when you don't want your parts to kind of move around and kind of cause some problems. Okay. What we'll do is we'll first assemble the pegboard and the stands together. So what I'll do is I'll press mate. So now mating is really what kind of attaches all of these parts together. Basically, we're kind of like giving these different relationships to certain edges and lengths of different parts, so they attach to one another. What I'm going to do is I'm going to bring this close together. I'll move it, kind of move it to the side, and what I'll do is, as you can see, we want this to fit inside that hole. I'll click on that edge right over there. Okay, click on that edge, and I'll line it up with. Okay, so now you see that it's kind of getting closer. It's not completely, we still have a lot of work to do, but it's getting closer. So what we'll do is now we'll select this and this one. Okay. Now you can see it's kind of fit completely inside it. Okay. So now it's completely fit inside that edge. We'll do the same thing on the other side. Okay. Well, we kind of want to move this in that direction, right? Just so that we kind of get a better understanding of what relationships to draw. So we can do the same thing here. We can put this edge connected to this edge. Okay. Like this edge, this edge. Now you can see have pegboard. So it's not moving. Everything's kind of fixed in place. You can fix one of these parts just in case the whole thing doesn't start moving. Now we'll do the same things with the pegs, but however, we're going to give it a certain degree of freedom, just because we don't want to kind of like jam it inside the holes. We want the pegs to be able to kind of move back and forth. We'll select the outer diameter, and this is going to be a concentric relationship with the inner diameter of that hole. Now you can see it's fixed in the hole, but it can move up and down. Okay. So we'll do the same thing with the square. This is not going to be a concentric relationship because this is, this was a circle, this is a square. We'll kind of have to use the face geometries to kind of align it. As you can see, those faces are now kind of coincidental or coincident. We'll do the same thing. We'll do one more. Okay. Now this can move freely up and down the hole. Okay. Now we have the last one. What I'll do is I'll kind of relate the same thing, the faces. You see sometimes that happens because yeah, you kind of want to move it around before because sometimes SolidWorks might not understand what you're trying to do. Like when it was kind of laying horizontally, if I tried to connect the faces, it wasn't working. However, it should work now since it's kind of in perpendicular to the pegboard. Go to mate, like this, that. You can start seeing that those two faces are coincident. We'll do the same thing with that face and that face. And now you can see it's completely in the hole. You can move this one freely as well. Okay, so that's pretty much it in terms of assembly. So now we have basically we have kind of the assembly with the 3 pegs, the pegboard, and the 2 stands. What we can do now is, let's say I wanted to add some engraving inside the pegboard, but I already created the assembly. What I can do is I can press on the pegboard. Okay. You can press edit part. Wait, first I need to save this. You need to save this. Once you save this, you can kind of tinker around with it. I'll call it assembly 1. I'll save it under downloads. Okay. So now I have access to the pegboard. I can see you can see these were the options that I had when I was creating the parts. So I can make some edits to this. The sketch, and I'll select this as my plane. I want to create some engraving. I want to write Cal Poly Pomona in the base of the pegboard. I'll select centerline, create this line. This is going to be the place where I'm going to insert my text. So on this curve, write Cal Poly Pomona. Okay. So once I have Cal Poly Pomona written inside, I can exit the sketch. And just like any other profile, we can extrude it, or we can cut it, or extrude cut, or we can extrude boss it. If you do this, it's going to kind of extrude outwards. If you do extrude cut, you can go kind of create an engraving inwards. I'll select so under pegboard, select sketch. You have to select the sketch so SolidWorks knows what you want to extrude. Press extrude cut. Now you can see it's kind of like sinking inside the base. We'll kind of give it 0.25 inches. Okay. Now you can see this is engraved, fully engraved into the pegboard. If we're done with editing the component, press that, and now we have a pegboard with pegs inside the holes. So this is our final design. Now what we can do is I can just show you how to make a drawing from this really quickly. Okay, so I'll press make drawing from assembly, and this screen will show up. I'll select B landscape. You can select whatever landscape you want. It's just different fonts, sizes. I'll select B. Okay. So what you want to do is you want to put pop here. Okay, so see how you can see, so it's providing me with profiles for the assembly that I've created. That way it's easy for us to kind of give it dimensions. And if we're going to have this manufactured, then we can kind of let the manufacturers know how long we want the ends to be, how wide we want the entire pegboard to be, and kind of make any kind of comments on the drawing, so they don't kind of mess up, and they provide us with what we want. Left, back. Okay, we'll put this one left here and here as well. Ultimately, this is kind of this is the isometric view, kind of the entire view of our part. This is the top view. This is the front view. And this is really the right view. And yeah, so just like last time, here's smart dimension. Select smart dimension. Okay, select smart dimension. And what we'll do is we'll kind of give these profiles the dimensions. So it will provide us with the same dimensions that we use, but it will kind of be in written form, which is going to be easier for them to kind of understand. If you recall, we kind of made the length of the ends 3 inches. We made all of the heights and the diameter of the pegs 1 inch. So if I select this and I press our dimension, you can see it provides me with a diameter reading of 1 inch, right? So, I can do that for the side view as well. It's really important that we have 3 different views, because as you can see, like in this image, we don't see the entirety of the drawing or the assembly. We don't know how tall it is. We don't know the depth of it. So that's why we have this other drawing. So we can give this smart dimension, and we can kind of indicate what the height is going to be, which is 4 inches. Same thing here. This is the right side. That's not something that you would see in any of these 2 drawings, or like this side, which you can use to kind of provide. or end length. Yeah, so ultimately, that's the basics of drawing. You can, you can write your title here. You can write project name here. Your name, date. You can provide any comments. You can say that this is made out of cast iron. Some parts are made out of cast iron. Some parts are made out of wood. You can specify color. You can specify anything that you need to specify. Yeah, here's material. So basically, this is kind of like a standard formatting. Go to sheet format. You can edit the sheet format. Right. So if you go edit sheet format, then you can kind of like type title in. Something like that. So that's pretty much the basics. And yeah, so we've kind of now have, let me just save it really quick. So now we have 3 different items, or 3 different things that we kind of worked on. Download assembly 1 drawing. Okay. Okay, so we have a drawing. We have a peg. Yeah, we have a peg. We have, we have all the pegs actually, and then we have, of course, the part that we drew and the assembly that we made. And then we have the drawing. Yeah, so any questions? That's pretty much it. So any questions in regards to any of these processes? If you guys will have any questions on like what else we can do with SolidWorks, maybe something that you would like to add.
Could you show me one more time how you got to this drawing view? I missed that.
The drawing view,
Yeah,
like from the assembly.
yeah.
Okay, yeah, sure. So this is the assembly, right? Get a file. Let's make drawing from assembly.
All right, thank you.
Yeah. So you'll get to this kind of sheet. Right. And anything else?
No, I'm pretty good now.
Okay. Yeah, if no one else has any other questions, then that's kind of it for this tutorial presentation. I would encourage all of you to kind of try out SolidWorks and kind of play around with it. Using SolidWorks is kind of like using, Microsoft Excel or using something like Word or PowerPoint. It's a really kind of intuitive software, and as you kind of use it more and more, you'll kind of get to know all the different tools that are at your disposal. We didn't use everything. Definitely there's a lot of different types of other kind of geometries that you can make. You can kind of, when it comes to assemblies, there are different types of mating. There's engineering mating, where you can kind of make spur gears and gears together, and you can make, kind of like different engineering materials together. You can create a bill of materials. You can do a motion study. How this is like moves back and forth. You can kind of create a motion study to show how this product or this kind of assembly will actually function. yeah, so there's a lot of things that SolidWorks has to offer, and I just encourage everyone to kind of like try it out, and it's really useful, especially for engineering students, and it's something that a lot of professionals do look for in in engineering students when they're kind of considering you for internships or jobs. Yeah, but that's pretty much it. There aren't, if there are any other final last questions, other than that, I think we're kind of done for the day.
All right. Thank you, Arya.
Right. Yeah. Thank you all for coming.
Hey, congrats on your first workshop. You're still recording.
Yeah. Let me pause.